Great. Well, welcome everybody. Thanks for joining us today at the noon hour for a continuation of our hemp webinar series. And we continue to add webinars to the schedule. And I think Catherine is getting ready to send out an update to the series. We have a speaker coming up in July that will be speaking on post-harvest hemp quality, storage, and potential issues that can arise if hemp isn't stored properly. So that'll be exciting and a topic people have hoped to hear more about. And I believe we'll schedule another webinar in July focused on pest management, because that was another topic people wanted to learn more about. So we'll just keep adding them. And again, if you have topics that you want to learn about, please put that in the chat box or email Catherine or I, and we'll try to get that scheduled. All right. So today joining us is Alex Escher, and many of you have heard from Alex before at our various webinars and conferences. He's spoken to us a few times about hemp fiber, and Alex is the founder of Hemp Hollow Processing, and he's the Director of Hemp Development at Escher Design, and has quite a good amount of experience with building with hemp. And he's a leader for US Hemp Building Association. And so he's going to be talking to us about building with Hempcrete. So welcome, Alex, and I'll let you take it from here.
Great. Thank you so much, Heather, for that great introduction, for sure. And again, it's always a pleasure being back and talking to you guys. So to begin, I think Heather kind of gave you guys a good summary about me, but yeah, it was good. I've gotten to do some reflection, and 2021 will actually be my 5th year working in the hemp industry. As most of you guys, as most of you guys probably know me from, is Hemp Hollow Processing. We do mobile trimming and bucking services for smokable flower, and we are very proud to be going into our 2nd year of operation, and we are currently serving all of Vermont and New York State. So, as deeply rewarding as this has been, as Heather said, I actually got my start in the hemp industry looking at building material. The story began in 2016. I was brought on by my dad's architecture firm, Escher Design, to look at green materials suitable for mainstream and high-end residential homes. The client that we had in mind for was looking for a material that was highly sustainable, but most importantly, could also be incorporated into regional design aesthetics. So the material needed to be something, not draw focus away from the design. So in my research, I came across Hempcrete and was really impressed by its sustainability properties, its fire resistance, and quite a bit of their engineering properties, and most importantly, its ability to be incorporated into existing aesthetics. So in 2017, following this research, I went up to oversee, and with a few other people, the first hempcrete structure in Denver, Colorado that was permitted. This is the structure here. It is owned by my good friend Eric McKee. It is a 320 square foot timber frame barn. All of the walls and roofs are currently made of hemp. The building was featured in a number of publications and is being used as a proof of concept to demonstrate its hemp potential as a mainstream construction material. It also led to the formation of the US Hemp Building Association, whose mission is to create the supply chain and regulatory framework to make hemp construction a reality for the modern American construction market. So to begin, I believe we're at a global transition point for not only construction, but really for environmental products in general. Especially in the past few years, I think the discussion around sustainability has really started to shift now that businesses and governments and consumers are starting to feel the direct fiscal impacts of the changing climate. The construction industry is in the unique predicament of being both the largest polluter and the largest consumer of finite resources. The industry is incredibly resistant to change and is still very, very heavily reliant on synthetic-based building materials, especially insulation materials like fiberglass and spray foam insulation. Although these materials are very cheap and abundant, they provide mid-tier performance, are very difficult to work with, and absolutely littered with toxic compounds. In fact, this is actually a much worse problem than people realize. The built environment is filled with toxic compounds sourced from synthetic materials. This has made compounds like, formaldehyde and other volatile organic compounds everywhere in the working environment and the home. Some of the most common places where you can find these are upholstery, carpeting, and different types of paints. Those have been a big problem. The impact of this has been absolutely enormous, with conditions like sick building syndrome becoming commonplace. The symptoms of this, despite them going under the surface in the beginning, are lower productivity, respiratory issues, and frequent headaches. This is a big problem, especially since the modern life requires the modern American worker to spend 80 to 90% of their time indoors. Right now, the American system of insulating buildings is essentially sealing everything into an airtight box and then relying on mechanical HVAC systems to control the humidity and the temperature. This has been an especially big problem, especially this year with the outbreak of airborne pandemics. These type of systems, especially in large office places, actually became a liability for big businesses. So this has actually gotten worse in many ways especially in the past few years, now that they're looking at this as not just for sick building syndrome, but for other sick-based syndromes as well. In order for meaningful progress to take place and to really find a root cause to this problem, change does need to start from the bottom, which really comes down to where we source our raw materials from. This is an example of what can happen with these HVAC systems too. Sometimes the mold can go right into the system and be basically the mold growth within the ventilation system is shooting right into the airflow, which the mold growth is a good catalyst for sick building related causes. So this is where natural materials come in, especially in the construction place. These have a number of advantages over their petroleum-based counterparts in this regard, most of which they're renewable and sustainable. They're very popular with consumers and they're non-toxic, meaning that they can be created without the addition of formaldehyde and other volatile organic compounds. So looking at green material here as which is widely looked at as the way to combat this. Essentially what the construction industry is looking for is a raw material that can be grown locally, sourced locally, remediates the environment, and also provides for environmental and health concerns of the occupant. But if we're looking at a raw material, what would be the best one to do something like that? So industrial hemp is a standout in this regard, but is relatively new to the national discussion, but is roots in being part of the world civilization dates much further back than the past few years. Hemp has been grown since at least 8,000 BC and is widely considered one of the oldest commodity crops grown by humans. It has been cultivated in every continent, in every part of the world by major empires throughout history. This ranges from ancient China to the Roman Empire to the British Navy. It was historically the backbone for many ancient navies, even cultures such as the Scythians, who were a precursor to the Huns. They would use hemp for bowstrings, as well as the British Navy, who would rely on hemp rope to keep their fleet seaworthy. The hemp seeds can be eaten, the fiber can be woven into fabric, and the flower can be consumed for plant-based medicine. Um, I'm sure many of you heard that hemp is the plant of 25,000 different uses. Where that statistic originated from is if you take all of the cellulose, cotton, and petroleum products, as well as soybeans, and all of those products can be made out of hemp. And when you add all of those together, you get around 25,000 different uses. So that's where that statistic originates from. So while I'm sure most of you know that hemp and marijuana are different plants, for those of you who don't know, the differentiation is that the hemp plant contains less than 0.3% THCA or delta 9, which is this is the psychoactive compound that causes you to get high when you're smoking cannabis. Hemp doesn't have any of that, for those of you guys who don't know. But anyway, there is a little bit more nuance to just that differentiation. There are actually 4 distinct hemp varieties. The first being CBD hemp. This is what 90% of the market is currently grown for. This is not surprising since it's the first hit mainstream product to come since the hemp has been re-legalized in the 2018 Farm Bill. The focus of the CBD plant is essentially to grow dense resin-rich flowers, which is used to produce CBD oil or to smoke as in smokable flower. Next, we get to grain hemp. This is grown for hemp seeds, which is pressed into hemp seed oil. These are one of these most nutritious foods found in all of nature and have a perfect balance of omega-3 and 6 fatty acids and also being very high in protein. So the bottom 2, we get to the fiber hemp. The one on the left is just regular fiber hemp. We will get to that more in detail in a second. The 4th one is the dual or hybrid variety. This is when hemp is grown for both seed and fiber production, opposed to just one of the raw materials. Some of the newer strains coming to market, especially the ones out of Canada, are actually including CBD and other cannabinoids in this. This opens up a lot of options, giving the farmer 3 to 5 raw materials from a single harvest. This is definitely a space to watch on the farming end and opens up a lot of different possibilities. So circling back to just the specialty fiber hemp. Hemp fiber is the fastest growing of the hemp varietals, with some regions being able to grow 2 crops per season. It can be grown in 60 to 90 days, depending on the strain. So it's also very, very high yielding, with an average of about 4 to 8 tons per acre. This can vary depending on the strain and the irrigation available for the farmer, but this is a pretty good mid-range for what you can expect from an early to middle-sized fiber farm that's not quite optimized yet. I would say in the 4 to 8 ton range. Unlike with their CBD cousins, where you get about 1,000 plants per acre, the fiber plants get about 100 to 400,000 plants per acre and are grown at about 30 plants per square foot. So this is very, very dense compared to CBD varieties. The crop is highly resilient to both pests and diseases, so fungicides and pesticides are going to be non-existent with this crop. It's an excellent crop for soil health as well. There's been documented evidence of it being used to clean up contaminated sites, ranging from heavy metals found at sites right around abandoned mines to even radioactive material. The Soviet Union experimented with using hemp fiber as a way of taking contaminated radioactive compounds out of the soil at the Chernobyl site. So this has amazing potential in the soil health region. It's also a very strong rotational crop. Hemp can return as much as 70% of its nutrients back into the soil, and there have been farms in the UK that have reported a 20% increase in wheat yield after hemp has been planted the previous season. So it's a very, very strong rotational crop and is very good for soil health. Finally, the carbon sequestration. Hemp has the fastest CO2 to biomass conversion ratio found in nature, even more than agroforestry. So essentially, when you're growing a hemp field, you're essentially growing a small forest in one season. And as you can see by the shape, these plants are like giant straws that suck up CO2 and store them in their woody and elongated stem. So processing for fiber is a bit different than on the CBD and the seed end. The goal of fiber processing is to separate the inner and outer bark of the plant, which this picture very, very clearly describes. This is done in a two-part process, beginning first with retting. Retting translates, in other words, you can think of this as like controlled rotting. Um, this is when the pectins and other naturally occurring fungi start to separate the outer bark of the plant from the inner bark, as we saw in that last picture. This is the beginning of the process. This can be done in the field or also in rivers, which was historically done in environments such as the Ukraine. After that, it is baled, where it can be shipped to a processing facility. And the final step of the separation process is called decortication. Historically, this was done with a handbrake, where a laborer would basically crank the elongated wooden machine back and forth until the fiber is broken before going through some post-processing phases. But luckily, in this day and age, we have mechanical systems to do this that are much more efficient and much less labor intensive. So after the fiber has been separated and it has gone through a number of post-processing phases, you're left with two key raw materials, hurd and bast fiber. So the bast fiber that you can see on the right is the principal raw material for fiber cultivation. This is one of the strongest and most durable natural fibers found in nature and a very high component of the plant. It is being used in a number of applications, ranging from demanding engineering products to consumer products. This is like a textile fiber, similar to that type of, that was where it was most commonly used in the past. On the left, we see the hurd, or the inner woody core of the plant. This is highly rich in cellulose and makes up 70% of the plant's biomass. It also has exceptional water absorption properties comparable to its small size. So although often considered a waste product in the cultivation process, since the bast fiber is more valuable on a price per pound type basis, the hurd is finding quite a bit of usage in absorbent-based applications such as mulch, animal bedding, and even to clean up oil spills. So the market for fiber are really, really numerous, but they fall into basically four major categories, give or take. Paper, textiles, plastic, and construction. First big one is paper. The term cannabis actually derives from the Arabic word for canvas. So you can see where the parallels are there. Unlike tree paper, hemp paper is very, very durable. It doesn't yellow or crack and can last much, much longer. It can be used in specialty papers as well as for lower end applications like toilet paper and tissue paper. Next, we get to textiles. As I said before, hemp has a long history of being grown for textiles. This has been done for thousands and thousands of years. The hemp fiber is very strong and durable while also allowing the fabrics to breathe. Not only that, hemp fiber is naturally antimicrobial, which makes textiles is finding a lot of applications in specialty fabrics such as medical scrubs and diapers and bandages, as well as jackets, which you can see here. This is a jacket line by Patagonia, who uses a hemp cotton composite that is really a wonderful, wonderful jacket that I would check out if you get a chance. Next is plastics. Both the grain and the fiber can be refined into a plastic product. This can be 3D printed, as you see in the picture, but the first big mainstream application for hemp fiber actually came from the auto industry. Many of the auto companies are replacing glass fiber and nonwovens for hemp fiber due to its durability and the fact that it's lighter weight. This lets you save fuel costs on the car and also increases the vehicle's shelf life. So number 4 is construction. Hemp has a number of applications and properties that make it very, very suitable for construction applications. One of which is that it can be grown locally and incorporated into existing construction practices. It is commonly said with hemp fiber that anywhere you can grow corn, you can grow hemp. So in order for a construction material to be mainstream, it really does need to be incorporated into local or at least regional supply chains. Hemp is absolutely a good candidate for something like that. It's very, very simple and renewable and easy to work with. This is one of the reasons that hemp is already, despite it being in the early stages of its growth cycle, it's already finding applications with do-it-yourself enthusiasts due to its simplicity. Some of these are in the basically mainstream staple construction products. You're seeing this for plasters, for hemp matting, for bat insulation, and for building materials, such as hempcrete. So hempcrete is a biocomposite made from mixing hemp hurd with a binding material. Modern iteration of hempcrete originates to the 1980s, where it was used in France for building restorations where Portland cement was not a viable option. However, that being said, the history of hemp use in construction, hemp mixes specifically, go back much, much earlier than the 1980s. The oldest known hempcrete structure still in existence and still operational today is the Sarthe River Bridge in France. This bridge was built in 500 AD and has withstood Viking conquests, multiple world wars, natural disasters, and the punishing current of the river below. A hemp mortar made of 10% hemp was the glue that kept the entire structure together and preserved the structure much more than many of the other regions in the building. This is a very, very important bridge for the history of the town and has survived longer than many of the other ancient buildings in the town, despite those buildings not being right above a large, fast-flowing river such as the bridge was. So moving to the other side of the world, Indian archaeologists have discovered that hemp played a massive role in preserving the Ellora caves in India, which is dated between 6000 and 1000 AD. The region where these caves were built is known to be a cultural center for the art form of Indian rock cut architecture, which you can see here. These are absolutely beautiful, and I would highly recommend looking this up if you're not familiar with it to see some more pictures. The Buddhist monks who prayed in this region, and what was interesting about this too is that this region is very, very highly prone to decay for these art forms, since the average annual humidity of the region is 70%. So the preservation of this type of artwork has been very, very difficult. The way this was handled was the Buddhist monks who prayed in these caves used a mixture of hemp, clay, and a lime plaster to preserve both the ceilings, the shrines, as well as the walls of the building. This not only provided a very, very tranquil atmosphere for meditation, but allowed the material, it prevented water buildup from within the material. Due to the cave remains one of the only buildings in the region to withstand over a thousand years of rainstorms and other humidity swings. According to the archaeologists and the building experts in the region, this is largely due to the hemp plaster because of its breathable nature. So finally, we get all the way to the Japanese town of Miyasamura in Japan. This home is 300 years old and still in operation, and this region actually has a 2,000-year history of growing hemp, despite Japan being an island, very different from India and France. Hemp is deeply important to the history and culture of this region, and this house is still in operation today, despite being 300 years old. So as you can see, the 1980s was the modern iteration of this, but the history of this material has a very, very ancient past. So as I said before, hempcrete is a biocomposite made for mixing hemp hurd with a binding material. It is highly sustainable, has excellent thermal and moisture handling properties, is very durable, and can be incorporated into a multitude of design aesthetics and be incorporated into regional and existing construction practices. Hemp homes have been built in a variety of climates. This range from the mountains of Idaho to suburban Denver, even to the coastline of the UK and Mediterranean climates. So in very cold and very hot climates, hempcrete buildings have been built successfully. In the United States, there have been about 50 hemp homes built. However, overseas in Europe specifically, there have been hundreds of buildings built. This is due to the fact that US regulations on industrial hemp production were much tighter than they were in Europe and other parts of the world. So the lack of regulations allowed those construction industries to be a little bit more ahead of us. A hemp wall replaces the need for bat insulation, drywall, house wrap, plywood sheathing, vinyl siding, and a vapor barrier. It is all packaged into the same material. The monolithic nature of the material makes it not only stronger, but it eliminates joints and gaps that lower thermal performance and gives the room a very solid overall atmosphere. So this monolithic nature of this material, everything is incorporated into the wall. So oftentimes hempcrete is compared to other insulation materials, but it's good to remember when looking at this that this is the entire wall. So hempcrete is comprised of 3 ingredients: hemp hurd, a binding material, and water. That's it, just 3 major ingredients. Lime is most commonly used as a hempcrete binder due to its vapor permeability, its durability, and its fast drying time. Both hydraulic and hydrated lime can be used in hempcrete mixes. However, that being said, the hydraulic lime is preferred by hemp builders simply because it has a hydraulic set. For those of you guys who are not familiar with the building science there, that means that the water, not air, initiates the chemical reaction that causes the material to harden. That being said, hydrated lime, which is much more common in the US, can also be used in hempcrete mixes, but is often accompanied by a pozzolan such as metakaolin to give it that hydraulic set. Once the water is mixed with the lime, it begins to calcify, going from a powdery form that you can see in the picture here back into limestone. The water is what initiates that transition, and it slowly goes back to its natural state that it was found in before it was refined. Once the low density and porous hemp hurd is added to the lime, it creates an intricate matrix of micro-sized air pockets within the wall. What this results in is a low density material that is highly durable, holds its shape even when wet, and maximizes the insulation value. Once the mixing is complete, the material is very fluffy and very sculptable, as you can see here. It can be incorporated into a number of different shapes and fit a number of different molds that the builder might need. So hempcrete is generally mixed in a pallet mixer, but you can do it by hand as well if you're working on smaller buildings. The next steps are pretty simple. After the material is mixed, it is poured into a framing apparatus layer by layer and then tamped until the desired density is achieved. The properties of the material are determined by the ratio of binder to lime as well as the compactness of the tamping. So lower density mixes are tamped less than higher density mixes. So yeah, there's a lot of customization available there. So after the material is placed into the framing apparatus, it's ready to dry. This happens in 3 stages. The first stage happens in the first 24 to 48 hours after the material is placed. This is where the majority of the drying takes place. It goes from a very wet, oatmeal looking material there. And after the about 24 to 48 hour mark, right when you get to the around that point, that's when it starts to hold its shape and you can remove the shuttering from that. The shuttering being the framing apparatus that the hempcrete was placed into. It then slowly begins to cure for around 28 days. This is when, after this point, this is much more gradual than the initial set, but after the 28-day mark, it is functionally dry. However, the drying essentially in phase 3 happens indefinitely. As the material gets harder and harder as the building ages. So as it does this, it actually absorbs CO2 to basically keep catalyzing the limestone as it gets harder and harder and harder. So the carbon sequestration of the drying products of the drying process for the homeowners is essentially indefinite, which allows basically a permanent but small carbon sink throughout the building's lifestyle. Concrete does this as well, but given the energy it takes to create Portland cement, these effects are fairly negligible. So after the 28-day mark, the material is ready to be plastered. This is both to create a air seal, but also for aesthetic purposes. After this time, the material can be painted as long as the paints are vapor permeable, usually a lime-based paint. Also, sidings and other finishes can be added, allowing a range of design options to be pursued by the building team. Again, I can't stress this enough. One of the benefits of Hempcrete is that you're not limited in the design space. So you do have a number of different finishing options that can work with a variety of different design and building styles. So Hempcrete can be used for wall applications, for roofs, and for flooring. The density of the mixture determines which application the material is best suited for. So a lower density mix, which maximizes the thermal performance, is generally mixed for walls and roofs, where that is commonly valued. Whereas in applications like floors, you generally have a more structural material, meaning it is higher compaction rates, and generally you use a little more binder to herd if you want to make a more denser material. Again, there is a lot of customization options available here. So it is entirely possible for the mix to be basically built or customized to the exact needs of the application in hand. While lime is commonly used, there are many other hempcrete binders available, some of which being clay, magnesium cement, and even Portland cement if you want a more structural based material. So Hempcrete is installed using essentially 3 different methods for installation. The first is cast in place. This is essentially what we just described above. The material is placed into a framing apparatus and tamped and in a framing apparatus, and the shuttering is removed once the material is dry. This is by far the most common form of hemp construction and has a lot of advantages, most of which is that it's very simple and low tech. Generally, hempcrete is used with a pallet mixer, but in cast in place, you can essentially do all of this by hand if you want to. It's very easy to pick up and go. It's the barriers to entry to learn this are much lower, and the material is much easier to customize especially for new mixers who, if you make a mistake or something like that, it's very easy to add a little bit more water, a little bit more lime, and just start again. The downside of cast in place is that it is the most labor intensive of all the styles, and it is generally the slowest. This is just due to the fact that you're limited by the size of the pallet mixer, and pouring by hand is functional, but it is slower than some of these other styles. The next is spray applied. This works by using a device similar to a cellulose sprayer. This sprays the material into the wall or roof cavity, and then basically it dries and holds its form from right there. This has a number of really big advantages to it, and is often starting to be used in commercial buildings. The main thing is that it reduces labor and time substantially on the build site. The minimal crew that you can use for just the hempcrete part of the job is like something about in the 2 to 3 people range, where cast in place is going to be double or triple that. You basically just need one person spraying and one person loading, maybe one guy on support. This method has also lowered the build times as much as 60%. So for a cast in place building that would take about 3 weeks, a spray applied building can be done in about a week. So that's a very drastic lowering of the rate there. This does have some disadvantages though. The main one is that these machines are still very much in development and not really available in the US yet. There's maybe only a few companies working on these. Even harder than the machine, there's maybe a handful of specialists who know how to operate these machines, and they do require training. Finally, some of them do require proprietary binders. So if you're looking to source everything locally, some of these machines may not be viable. That's just some of them. Some of them you can use local products as well. Finally, we get to cast in place. European companies such as Donna Agro and Canadian companies such as Just Biofiber are working on hempcrete building panels and blocks. These are made in off-site facilities and then brought to the site. This has a number of advantages. One main one is that you're outsourcing the mixing to a third party. So the specialist part of the hempcrete aspect of the job is outsourced to people who've been who are specialists and be building a lot of these all the time. Second is that this is one of the fastest, if not the fastest, building method, especially on building panels. Since the building panels are already dry, they can be plastered the day they arrive on site, and are pretty easy to snap in place into a foundation. So the build times can be maybe 1 to 2 days if it's a good system that you're using. The main downside to this is the upfront costs for these type of facilities that work on manufactured hemp products are very, very expensive. So this is still at its very, very early stages and not really available in the US right now. In the future, this will change. So despite the name sounding like concrete, hempcrete is not a foundational material. It is an infill and insulation material. You can increase the structural properties of hempcrete by using binders such as Portland cement. However, this is not really the best use of the material. It is not where the material really shines compared to its counterparts in the green building space and in the mainstream construction space. These are the properties that really define what constitutes why hempcrete is really a breakout star in the green building world. Let's look at some of these in detail. So first is the fire resistance. Hempcrete is highly fire resistant due to the presence of the lime binder. Hemp homes are capable of withstanding temperatures of up to 5,000 degrees. And yes, both European and American burn tests have confirmed this. When the tests were performed, there was nothing ignited, burned, or smoked while this took place. As you can see in this picture, I think you guys can see it right here. Move that over there so you guys can see it. There's some slight charring on the surface, but overall you can see the structure of the material is still very, very much intact. It's not compromised by the high temperature of the flame. And again, that's a propane blowtorch put right at the surface of the material. In the most recent ASTM test recently performed, hempcrete actually got a perfect score. This was due to the fact that there was zero flame or smoke spread. So from a fire perspective, the data is there and it is very, very positive on the hemp end. So next is the thermal properties. Hempcrete has really, really great thermal performance due to its its high thermal mass and low thermal capacity, and low thermal conductivity. Air pockets within the wall system allow heat to be stored within the wall matrix, which impedes the flow of heat from one side of the wall to the other. With the addition of the lime plaster, this further impedes the air movements while not providing a perfect seal. That's what's really, really key about this. What this translates to is that the wall breathes and passively regulates the temperature of the building, resulting in rooms that are cool in the summer and warm in the winter. This can also buildings that are very, very comfortable to be in. This is actually also led, this is optional, of course, but this is very, very different than how conventional insulation materials that seal everything in and then require a mechanical system to remove the extremes of the temperature spectrum. European homes with hemp walls have actually been able to remove these systems entirely, basically relying on the hemp wall for all of their to keep the energy or the temperature consistent enough, and don't really need these systems. Obviously, this is optional and very much dependent on the lifestyle of the occupant. But for those who have incorporated that to its fullest potential, they've reported savings of up to 60% on their energy bill. So this is a good demonstration of this here. In this chart, you see that that this is monitoring for both external temperature and internal temperature. This is a hempcrete wall being tested in real time without an HVAC system or any mechanical apparatus. The red line you can see is the external temperature. We could see that this is absolutely darting all over the place, and the orange line stays very consistent, which is the indoor temperature. This is where this creates rooms that are very, very comfortable to be in because the temperature is consistent and you don't need to jack up your energy bill in order to maintain that. So next is the humidity properties. Just like with hemp temperature, Hempcrete can create an internal humidity that is consistent. Homeowners can enjoy a relative humidity of about 55%, with the wall system absorbing and releasing excess water particles. The term for this is hygroscopic. Just like with temperature, this creates buildings that are cool in the summer and warm in the winter and can maintain a constant humidity of around 50 to 55%. So this is another demonstration of this here. Just like with temperature, the green line, you can see the outdoor relative humidity is darting all over the place, but the indoor humidity is very consistent. This makes it so that hempcrete performs very, very well in wet environments like the UK, since the excess moisture does not get trapped in the wall system. Again, this is very, very different from airtight insulation systems where water damage trapped within the wall system can create mold growth or cause the entire wall to fail. So let's understand the properties of how this works a little bit clearer, because this is really key to fundamentally understanding what makes hempcrete a breakout in this regard. So this is the microstructure of the hemp herd viewed through an electron microscope. As you can see, the hemp herd, which is the inner woody core of the hemp plant, is filled with these micro-sized capillaries that you can see here. These form to move water from the bottom of the plant all the way to the top of the plant. This can be up to 15 feet. The structure allows the herb to absorb a disproportionate amount of water comparable to its small size. When the spongy woody material is mixed with a vapor permeable binder like lime, the micro-sized capillaries absorb the excess water, store it within the wall system, and then release it. Because the wall system is open, meaning vapor permeable, the water does not slowly accumulate in the wall. It breathes. This is why the Ellora caves are still in operation today. This was the caves in India that were able to last for thousands of years. It was because of this property where the breathability creates a situation where there's no water buildup. Not only does this property allow buildings to be cool in the summer and warm in the winter, as I said, but in wet environments where you're getting a lot of rainstorms or by the coastlines of the UK, this can create walls that are much more resilient than when it's sealed completely. So next we get to mold and pest resistant. The hempcrete wall is very, very resistant to both mold and pests. This is again due to the presence of the lime binder. Mold grows at a pH of between 3 and 7. As most of you farmers will know, lime is alkaline with a pH of 12. Also, going back to the humidity properties that we just talked about, because there's no water buildup, mold growth within the wall system is going to be very difficult and non-existent at all. So this, to put together, makes a very, very inhospitable environment for mold. As far as pests, slime is a skin irritant for pests, just like it is for humans. When you're mixing lime, you do need to wear protective gear, but when the lime is solid within the wall, then it's the opposite. It's very, very healthy, unless you're burrowing through it. So I don't recommend trying to eat or nest in the wall system, which is why rodents and insects are not going to be eating your hemp wall. Next is durability. Hempcrete is highly durable with walls lasting for more than 100 years, as you can see with some of our earlier examples. There is minimal to zero maintenance required for hemp walls due to their very low tech and very, very resilient. If a wall does need to be replaced for whatever reason, a new batch of hempcrete can be mixed. It can be reapplied to the wall, no problem, and dried and plastered. And if it's done by a hempcrete builder or you've gone through this again to build the house in the first place, it should be it should be you shouldn't see any difference there. So it's very, very moldable and very, very durable even over long stretches of time. Hempcrete is not only carbon neutral but carbon negative. That means it sequesters more carbon during its production than it does in the in the production of the material overall. Again, to understand this, we go back to the raw component parts. The hemp herd or the hemp industrial hemp plant has the fastest CO2 to biomass conversion ratio found in nature, even more than agroforestry. While the lime does produce a somewhat substantial carbon footprint when it's produced, when it's created, it's much lower than Portland cement, and still due to the high sequestration in the growth and build phase as the wall sequesters, it's still carbon negative even with the added lime. You can also use more environmentally friendly binders like magnesium cement and clay as the binder. Those are a little bit more expensive, but you can make the carbon negative even more so if you do that. Not only that, Hempcrete is both carbon negative for operational and embodied carbon. So that means that for both the production process, it's carbon negative, as well as when you add the heat and energy savings caused by the operation of the Hempcrete wall. So this is a double whammy on the sustainable end. Hemp hurd is a natural agricultural byproduct, and lime is an earth-based material. Both can be produced with no toxic additives or any volatile organic compounds added to the production process. There's also zero off-gassing at any point in the production. The alkalinity of the lime prevents mold growth while also passively regulating the humidity. The breathability of the material inhibits the spread of viruses and bacterial infections that also thrive in these wet environments, especially in the ventilation systems like this example here. So yes, in high humidity environments, you are more susceptible to mold and sick building syndrome, sick building related mold applications, as well as airborne viruses. So so a natural building material like hempcrete is a very good solution to fixing a lot of the root causes for sick building syndrome in buildings. So as I began with, one of the winning parts about hempcrete is its ability to be incorporated into different regional aesthetics without drawing focus. This is one of my favorite hemp buildings in the world. It's called the Elon Hood Home in Israel's Haifa district. It was built by an architecture firm based in Tel Aviv called the Tav Group, and is what I love about it so much is that it seamlessly blends the environment and demonstrates how it seamlessly blends into the regional environment, and also demonstrates how elegant this material can look in the hands of a talented design firm. This is a Mediterranean climate too, and it features natural air cooling and a ventilation system as well. All of the walls are made out of hempcrete, and this is one of the star materials of a very environmentally a very environmentally suited home that was demonstrated for what it was built for. These are two of my other favorites. The one on the left is built in Asheville, North Carolina. This is referred to as the Push House. This was the first hempcrete home built in the U.S. It was actually owned by the mayor of Asheville and is still in operation. It's 3,400 square foot and designed by architect Anthony Brenner and built by the American Lime Technology. The second one on the right is the Highland Hemp House. This was a retrofit of a 45-year-old building, and at one point, I believe, was actually the largest hempcrete building in the country. The building's owner, Pamela Bosch, loved her hempcrete house so much that she's now become a national advocate for hemp building in the mainstream construction sector. So next we get to here's some commercial examples. While we've focused mostly on high-end residential homes, which I think demonstrate the elegance of the material, in my view, the future of the material is actually in commercial and large-scale buildings. The Triangle Housing Project in the UK, this is a 42 home residential development that was a sustainable development that is being used as a prototype for a much larger development that they're hoping to be about 200 houses. The one on the bottom is this one is the largest hempcrete building in the world. It is 210,000 square feet, and also the largest retail building in the UK. This was actually built out of building panels. So this is being used as a proof of concept for large scale hempcrete buildings, and they've noticed some amazing energy savings using a hemp based wall system, even on a large scale. Finally, we get to apartment complexes. This was designed by an Italian firm and was an urban regeneration project consisting of 42 apartments. The project was part of an effort to replace urban abandoned industrial sites with highly sustainable housing. It features passive solar and natural ventilation, as well as a hempcrete wall system. In the future, I can see a lot of hempcrete buildings, buildings like schools and auditoriums, and even potentially medical offices being a very, very great use of commercial hempcrete projects. So although the material is very simple, that doesn't mean it's foolproof, and that it doesn't have some bottlenecks that we still need to address before it can really take off. These are the four major bottlenecks that have prevented hempcrete from really penetrating the mainstream market. The first one is the lack of fiber genetics. Due to the restrictions around hemp up until a few years ago, a lot of fiber genetics need to be brought over and acclimated to American soils before they're ready to be scaled. UVM has been doing a fantastic job doing research and trials into this end, but this will still need a bit more work to make sure that it can be incorporated into a number of distinct environments. Processing infrastructure. When we go back to decortication, most of the hemp hurd that's being used for building right now has been processed overseas and grown overseas. The reason for that is all of the large-scale processing infrastructure is overseas. So that's been forcing all the importing of hemp hurd, which has been, more than doubling the price of what it should be, just in shipping costs alone, never mind processing costs and everything else. Certification. Right now, hempcrete cannot be used for multi-story homes or commercial buildings, since the regional building certifications are too varied across the country, and no national building certifications exist. One of the iterations of this is an R value. Hempcrete has a static R value of about an R2 per inch, but a dynamic R value of around an R4 per inch. This means that when it's tested in a sterilized laboratory, it performs in an R2 per inch, but when it's dynamic, meaning that you're testing the walls in the field with natural environments, it tests, almost double than that. Surprisingly, this is the exact opposite of how most building materials test, and is a issue more with how building materials are tested in the US more than with the material itself. This is something that's being worked on, and and the ASTM and ICC have been fantastic working with the USHBA on solving this issue, but it is still a limitation in preventing formal certification by national building codes, despite having foreign building codes and hundreds of examples of anecdotal evidence. Finally, is lack of public awareness. Most people don't know anything about hemp for building, and even in the construction sector. So education is vitally important to make sure the consumer and building professionals are aware that this material is available, and it's a good choice for a lot of different applications. So the good news about both of these four things is that they are being fixed. They can be overcome, which will bring the price down substantially. Right now, in environments where hemp is grown locally and the processing infrastructure is there, hempcrete is only slightly more expensive than conventional insulation materials. That being said, it's also the entire wall system. So a lot of the comparisons between a hempcrete insulation and a bad insulation, I think, are sort of missing the entirety of the equation. However, the US Hemp Building Association has been fundamental to solving a lot of these bottlenecks. They are active at every role of solving the issues that I just described. This involves building detailed supply chain maps for both farmers and for entrepreneurs looking to get into processing, as well as working directly with the ASTM and the ICC to develop sampling standards for in order to perform these building tests and bridge the balance between static and dynamic R value, issues like that. If you're interested in joining, my contact information is in the is at the end, but we are definitely looking for new members, and you definitely, if you want to be involved, I would highly recommend signing up. So to put it simply, the hemp plant is nothing new, despite it being a pretty recent event that this stuff has been able to be legalized and grown on a large scale. It is a very ancient material that has been cultivated by humans for thousands of years, and this last century of prohibition has been an anomaly in the timeline of human history. It is renewable, sustainable, and perfectly balances the needs of the environment with the needs of the community. I will note that although we do have some challenges ahead, no new technology is needed to make a hemp wall system a reality, and that day may be coming sooner than you think. So if you're interested in learning more, here's some really, really good books on the subject. I would recommend starting with The Essential Hempcrete Construction. This is available on Amazon and was written by Chris Magwood. He gets the basics really, really, he can explain the basics of this really, really clear. And then I would move on to some of these other books after that one. Feel free to reach out to me if you're interested in joining the USHBA or this presentation inspired you to look at building a hemp home. I am working with Escher Design and we have a number of hemp projects in the works right now. So yeah, absolutely feel free to reach out at any point. I believe we still have some time for some questions. Heather, am I correct about that?
Yes, absolutely.
Great.
So there are a few questions in the Q&A box. And Mayra has typed in a bunch of different questions and welcome. Thanks for attending the webinar. An architect from the Mass Design Group and a couple other colleagues are listening in. So they're not able to stay for the Q&A, but they have a couple of questions and their emails in the email box. You can see that hopefully, or grab that, Alex, so they can connect with you.
Right, sure. I'll make sure to do that. And again, my email address is there, so if whatever reason, if you want to email me the question, I can get back to you as soon as I can.
Yeah. Okay, we can make sure you get the email as well, because it sounds like they left.
No problem.
And they wanted to know if the hempcrete wall needs to be plastered to perform as a vapor barrier and minimize moisture absorption.
It generally plaster is applied. Some hemp wall systems have been able to not use any plaster type of thing. So the projects that I've worked on, the plaster has been applied, but it's not necessarily a requirement, but it does enhance the property substantially. So generally it's recommended to plaster, but there have been instances where it is not.
Great. There were a couple of questions about, what's kind of happening in New England. Are there any cooperatives? Are there any textile producers? Any updates on?
As far as I know of, some smaller groups that are putting the infrastructure in place. The issue with textiles specifically on the manufacturing end is that those do require on a large end economics of scale. So the manufacturing for that may still be overseas on the textile end. There are groups that are working on it, and there are small artisan producers in the state of Vermont and New England. But again, for these scalable applications, most of the what's been preventing that is more of the bottlenecks that I just described, where the decortication technology exists, but it's not quite dialed into the needs of there's a lot of operational stuff that needs to be, and teams that need to be trained. So that's more of the limitation, but there are some artisan producers, yes. Oh, Heather, I think I just lost you.
Sorry,
No, no
I
worries.
muted myself.
No worries.
Yeah, there's a question about, does Hempcrete meet passive house standards?
I believe it does, yes. One of the this is one area where the US Hemp Building Association is working on getting the formal certifications there. There have been a lot of there have been a lot of tests on the life cycle of the wall systems and how going through each step of the production chain and evaluating the carbon output per step. However, these do need to be performed in North America using North American products. So yes, Hempcrete is an excellent choice for that type of certification, but again, this is more that the tests just need to be performed. So this is where organizations like the USHBA are working on that right now.
Great. There's a question about the process for producing hemp insulation, and how does that differ from hempcrete?
This is the bat insulation.
I think so. It just says producing hemp insulation.
The bat insulation uses the hemp fiber. If you remember from the fiber slide, that's the outer bark and the textile fiber. That's produced by spinning it into the shape of the bats. Hempcrete uses the hurd of the plant, meaning the inner woody core. So yeah, the production process is different there. I mean, the good news about hempcrete is that you don't really need the hemp bat insulation with that, since the insulation is just a property of the wall system.
Great. My understanding is that concrete only carbonates when exposed to air, so it doesn't occur once plastered. Is this the same for lime hempcrete?
This is where the limes in a lot of the North American limes do have the air is what causes the hardening process. I'm not entirely sure on the concrete perspective, but no, that's not so much an issue there. With the you still get because it's an open system and it's not sealing everything in. You do still get some of that carbonation. Again, this is one of the tests that does need to be performed, is to do exact values of how much is sequestered in that third stage of the wall type of thing. I mean, it's going to be very gradual, but again, with 100-year life cycle of the wall, even like a little bit of that little bit of hardening can add up. But no, the plaster does not negate any of the thermal or humidity properties.
Great. I'm just looking here if there's any other questions. People are wondering about if there's a list of regional resources for hemp blocks and the panels. Is there a place to get those regionally?
Not regionally, no. The problem is right now is that these facilities are these facilities, the upfront costs are very, very steep for them. And as of right now, the local supply is just not there to support a consistent facility like that. That being said, that is a momentary issue. These will inevitably start to pop up as hemp production starts, as industrial production starts growing, even slightly in some local regions. But as of right now, the blocks and the paneling systems are mostly overseas.
Great. Is there, this is a question for me. I feel like there is some work. Is there any building places in Quebec?
Quebec.
You know
I don't know about Quebec specifically. I know there are some Canadian companies in the Manitoba, Alberta area.
Okay.
If I hear of any of them, whoever asked that question, I can shoot them to you.
All right. Thank you, Alex. That was great. I think that's most of the questions that were there. Oh, wait, there's one more about hemp being sort of this used as a remediation tool and accumulating heavy metals, etc. And then, are there any concerns then using that as a building material?
As a building material, no. As a food supplement or for CBD, absolutely don't do that. No, that's probably, especially in the radioactive sense. I will stress that again. Do not try to eat hemp seeds that have been, grown at, radioactive sites. But no, for the building, because it's, because it's accompanied in the lime and you're not, eating your wall or anything like that. That's where this is a potential a long-term storage for the heavy metals and the junk taken out of the soil. This because, again, because American production, the trials haven't really been done in North America. There haven't been like American certifications for that. But yes, on the building end, this would be a excellent long-term storage from that. So you wouldn't just burn the hemp or something like that afterwards.
Yeah. There are a couple of efforts underway locally. I know there is a business trying to get started in St. John's Ferry, Zion Growers. They're looking at growing fiber, not necessarily for building, but maybe potentially. And they're trying to set up some equipment, like I said, in St. John's Ferry. I know they're very interested in textiles in particular. Mm-hmm. And then there's another group, actually, I believe out of Massachusetts, that's working here locally with a local farmer, and they're taking their hemp. I thought they were bringing it to Canada for processing and then bringing the material back and making their own hempcrete and putting up a building in Massachusetts. You may know them, but yeah. Great. Well, I think there'll be a lot more to come, as you've mentioned, Alex, and we just appreciate you keeping us informed. Yeah. And hopefully we'll have even more to talk about in the future.
Yes, I believe we will. Again, if you feel free to reach out to me if any other questions come up. My email address should be on the last slide.
Great. All right. Well, thank you. And thanks everyone for attending today and all the great questions. As I already mentioned, we have a webinar scheduled towards the end of July, and we welcome you to come back. We may schedule another one in here before that. And Catherine will keep sending out announcements, Catherine and Susan. And thanks everyone, and go enjoy the rest of the beautiful day. Thank you. Thanks, Alex.
Yeah, take care. Thank you so much, guys.
Bye.
Bye. Bye. Thank you, Alex.